This question is from JEST 2017 and is from the topic dimensional analysis, but we are doing it as a part of QM PYQ series because of the presence of wave function psi, which is pretty much part of quantum mechanics. So we are asked to find the dimension of h cut by I del psi by del x. Let's first find out the dimension of h cut. So dimension of h cut is dimension of h divided by 2 pi. So this is dimension of h. And we are familiar with the equation energy E is equal to h nu. So this implies dimension of h is equal to dimension of E divided by dimension of nu, where nu is the frequency. So dimension of energy, if you don't remember it already, you can find it out. Energy is similar to work according to work energy theorem. So work divided by nu. Work is nothing but force over displacement. So this is dimension of force times dimension of displacement. Displacement is length. So dimension of length divided by nu is frequency. Frequency has dimension of per second. Therefore dimensions of h is equal to dimension of force is dimension of mass times dimension of acceleration, because force is mass times acceleration. Dimension of mass is kilogram times dimension of acceleration is meter per second square times dimension of length is in SI units it is meter divided by, there is a per second here, so this is equal to kilogram meter square per second. This is the dimension of h. Now I has no dimension, I does not have dimension, I is dimensionless. Now we have to calculate the dimension of del psi by del x. Del psi by del x dimension. Let's calculate first the dimension of psi. So we are told that the wave function is in 2 dimensions. So when we integrate modulus of psi square over all space in 2D, this must be a finite quantity, or it must be 1 if psi is normalized. So from here in RHS we have dimensionless quantity, dimensionless. Therefore LHS must also be dimensionless, and dx dy has dimension of L square. Therefore dimensions of psi mod square must be 1 by L square. This implies dimension of psi must be 1 by L, which in SI units is per meter. Now if you take the spatial derivative of psi, then 1 power will become less. Therefore dimension of del psi by del x will be m raised to minus 2, meter raised to minus 2. So dimension of h cut by I del psi by del x is equal to dimension of h times dimension of del psi by del x. Dimension of h we have already found that it is kilogram meter square per second. Kilogram meter square per second, and dimension of del psi by del x is 1 by meter square, or m raised to minus 2, m raised to minus 2. Therefore the dimension of h cut by I del psi by del x will be equal to kilogram per second. So the correct option is option D. Kilogram per second is the correct answer.